Most people don't have a memory problem. They have a retrieval problem. You don't need more notebooks, more highlighters, or another round of just try harder to remember. What you need is a protocol that rewires how your brain stores and retrieves information so that it's available on demand when it actually matters. Because here's the truth, your ability to recall useful knowledge under pressure is a competitive advantage. In a meeting, in a negotiation, in front of a client. When others freeze or ramble, you either deliver precisely or you fade into the background. And the reason most people fail isn't because they didn't learn. It's because they never installed the retrieval mechanism correctly. This video is your installation manual. Think of your brain like a high-speed storage system. But without proper tagging, even the fastest system turns into a black hole. You put data in, but good luck pulling it out. The fix? You don't memorize harder, you encode smarter. Neuroscience calls it retrieval-based learning. But what matters is this. The way you input information determines how your brain stores the file, and whether it can ever find it again. Most people study with their eyes. High performers retrieve with intent, and that shift changes everything. So here's what you're going to learn. The Retrieval Rewiring Protocol is a three-phase system to permanently upgrade how you store and retrieve knowledge. Phase 1 is called active encoding. This is where most people already fail. They absorb passively. Watch videos, read slides, nod along. The brain doesn't store passive input, it discards it. Active encoding means the information must be reprocessed in your own words, ideally within 90 seconds of exposure. You watch a segment, you immediately close the source, and then say out loud what the core idea was using your own vocabulary. Not reciting, reconstructing. This creates what's called desirable difficulty, a concept from cognitive science. The effort itself strengthens the neural pathway. The second tool in active encoding is spatial anchoring. Here's how it works. While reviewing a concept, you deliberately associate it with a visual layout. That could be a mental image of a room, a location on your screen, or a gesture you link to the idea. The hippocampus, the part of your brain that handles memory, loves spatial context. It evolved that way. This is why you can remember where you parked your car on Monday better than what someone told you in a meeting. So, you use that to your advantage. For every new piece of knowledge, you tie it to a place in a mental structure. That structure becomes your recall map. The third tactic in phase 1 is microsynthesis. After each learning block, no longer than 20 minutes, you generate a one-sentence summary that answers one question. What problem does this information solve, and how would I explain it to someone who doesn't care? This does two things. One, it locks the idea into your prefrontal cortex through active decision-making. Two, it increases relevance, which is key to memory retention. Your brain stores what it considers useful, not just interesting. At this point, you've installed the first layer of memory encoding. But without retrieval stress testing, it won't hold under pressure. That's why phase 2 is coming next. Because what you do after encoding is what separates amateurs from strategic operators. The ones who can speak without notes, pitch without prompts, solve under fire, and that's exactly what you're going to learn next. Now you move into phase 2, stress-based retrieval. Because memory that only works in silence with zero distractions is not memory, it's a liability. You need information that can survive pressure. That can be pulled instantly while your brain is under load. Whether it's during a high-stakes pitch, a rapid-fire Q&A, or a decision that has to be made with incomplete data, your ability to recall the right tool in real time is what sets you apart. So the second phase of the Retrieval Rewiring Protocol is designed to train your brain like a precision recall weapon. It's not about remembering more. It's about pulling the right data at the right moment without hesitation. Here's the core mechanic, retrieval under friction. And this means deliberately testing recall when your brain is not in ideal conditions. The first tool for this is something called rapid cue testing. After you finish encoding information, whether it's from a book, a course, or a training, you come back the next day. Not with notes, not with the source, but with a blank page and one question. What do I remember right now, cold? You then generate bullet points for everything you can retrieve without assistance. This forces your brain to treat information like a resource it has to own, not rent. But here's where most people fail. They stop when the recall is low. That's exactly when the neural rewiring starts. When your brain struggles to find the answer, that effort deepens the memory trace. It's not comfortable, it's effective. To amplify this effect, you stack in friction. You do your retrieval during noise, while walking, while tired, while distracted. This teaches your brain to pull information under load. The more you stress the system during training, the more stable it becomes in the real world. The second tool is cross-context triggering. This is where you simulate different environments while recalling the same information. You review a concept at your desk, then you retrieve it in your car, then in a cafe, then while standing. Why? Because the brain ties memory to context. If you always study sitting still in perfect silence, you'll only recall in that exact environment. You want your memory portable, not fragile. Cross-context retrieval creates generalization. That makes your knowledge operational in real conditions. The third tool in phase 2 is something I call constraint rehearsal. You give yourself limited time, limited words, or limited space to recall an idea. For example, set a 60-second timer and explain a concept as if you're pitching it to a skeptical executive. Or restrict yourself to only 3 bullet points to describe a complex framework. Why does this work? Because your prefrontal cortex thrives under constraints. It forces prioritization, compresses noise, and boosts executive retrieval speed. And speed is leverage. At this point, you've done what 99% of people never do. You've built recall that actually works under stress. But the protocol isn't finished. There's one more phase. Because true retention doesn't just survive distraction, it endures time. The final layer of the retrieval rewiring protocol is what locks the knowledge into long-term storage and makes it available when you need it, weeks or months later. And in the next section, you're going to learn exactly how to install that long-term layer so your ideas don't just stick. They become automatic. Phase 3 is called long-term locking, and this is where your memory stops being situational and becomes structural. Anyone can recall something they learned an hour ago. But when you need that insight 2 months from now, in the middle of a high-pressure decision, that's when you find out whether your brain installed the data or just borrowed it. Long-term retention isn't about reviewing more. It's about reviewing at the right time, in the right way, with the right spacing. And neuroscience is clear on this. If you don't actively force retrieval over time, your brain will treat the information as irrelevant and flush it. That's not a flaw. That's optimization. Your brain is constantly pruning to avoid overload. So your job is to tag what's important and prove to your brain it's worth keeping. Here's the tactic: spaced retrieval reinforcement. The moment you've learned something, you trigger the first review after a short delay, ideally 24 hours later, not with passive rereading but with cold recall. You test what you can retrieve without help. Then you wait 3 days, then a week, then 2 weeks. Each time you stretch the interval. This matches the natural decay curve of memory and signals your brain to rewire the connection for permanence. The name for this is the spacing effect. But the key isn't just the timing, it's the difficulty. You must allow the memory to degrade slightly before retrieval. That little struggle is what deepens the trace. It's the difference between cramming and mastery. The second tactic is layered context switching. Every time you review a concept, you change the angle slightly. Let's say you learned a framework for negotiation. The first time, you explain it like a teacher. The next time, you apply it to a real-world scenario. The third time, you compare it to an opposing framework. Why does this work? Because every time you re-encode the same knowledge in a new wrapper, you build additional neural pathways to it. It's like reinforcing a file with multiple tags. So when you need it, under pressure, your brain has more access points. It can't just vanish. You've created redundancy. And redundancy is what protects elite performance. The third tactic is strategic reactivation. This is where you deliberately connect old knowledge to new incoming data. For example, when you learn a new productivity technique, you ask yourself, which past principle does this build on, challenge, or contradict? You're forcing your brain to run a cross-reference. That activates prior circuits, pulls them into working memory, and keeps them alive. The more connections you make, the more resilient your memory becomes. In network neuroscience, this is called integration. But all you need to know is this: the more often you make your knowledge interact, the less often it disappears. Now here's where you go beyond retention and into automation. Once you've locked a concept through spaced, contextual, and integrated retrieval, your brain begins to use it without conscious recall. It shows up in how you make decisions, how you explain things, how you solve problems. That's the ultimate goal. You're not building a trivia database. You're engineering a second layer of cognition, a kind of internal operating system that can think for you while you focus on execution. That's what gives high performers their edge. They don't remember more. They access faster. And their decisions are built on a foundation that others don't even know they forgot. Now that you've installed all 3 phases of the retrieval rewiring protocol, there's one more layer that separates operators from learners. You've built the system. The final phase is about deploying it where it counts. That's what comes next. This is where strategy meets execution. You've built the retrieval rewiring protocol, but now it needs to be deployed in your performance environment. Because knowing something in isolation means nothing. The top 1% don't just store information. They weaponize it. They build decision layers, communication layers, and tactical layers around what they know, so it translates into visible leverage. That's the final install. You make knowledge actionable. The faster you can retrieve relevant information and translate it into output, the more dangerous you become. So here's how you do it. First, you create what I call performance triggers. These are environmental or behavioral cues that prompt recall in real time. Let's say you're in a sales call and you've embedded a pricing objection framework. Your trigger might be the first time the client says too expensive. That's your internal signal. You trained the retrieval under stress. Now the cue pulls it out. The same applies to public speaking. You might anchor your opener to a specific gesture or phrase that activates the rest of the content. What you're doing is bridging retrieval with performance, so the recall is seamless. No searching, no hesitation. It just fires. Second, you practice micro-deployment. This is where you take concepts you've installed and deliberately drop them into real conversations, decision-making, or writing. You don't wait for perfect moments. You create friction to test the system. For example, when discussing a challenge with a colleague, you inject a framework you've encoded and observe how it holds. This forces active retrieval under live conditions, and the benefit is twofold. 1, you reinforce the memory. 2, you integrate the knowledge into your functional identity. That's what separates readers from operators. The information becomes part of how you move. Third, you build an active repository, not a notebook, not an app you never open. A system you interact with. High performers don't archive knowledge, they circulate it. Every week, you do a fast scan through your top frameworks, principles, and mental models. You don't reread. You challenge yourself to rephrase and reapply. This isn't review, it's reactivation, and it keeps your internal playbook sharp because information decays. But when you make it move, it compounds. So now the question is this: how many ideas have you lost because you couldn't retrieve them when it counted? How many insights did you once have only to watch them vanish under pressure? The retrieval rewiring protocol is the fix. It's not about remembering everything. It's about remembering the right thing, at the right moment, without needing time to think. That's power. That's speed. That's separation. If you're ready to build a mental arsenal where knowledge becomes kinetic advantage, then this is your moment. Subscribe to Success Code and start engineering the systems your competition doesn't even know exist.